All right, let me go ahead and pull up my slides. So let's go ahead and get started. My name is Zach Snyder, and I am with the nonprofit Solar Oregon. I am super thrilled to have you here for this webinar. This is a webinar that we put on periodically, once or twice a month, and it's always fun. I always enjoy it. It's about exploring how to add solar and storage onto your home or your business. And so I'm excited to dig into this with you all today. I see people still kind of hopping on, so welcome if you just joined. This is our agenda. This is what we're going to cover. We're going to start off with a look at how solar works. We're going to take a look at a solar system, talk about the process of net metering. Then we are going to talk about your site, your home or business where you're considering solar, and what makes a site good for solar, what can cause some, create some hurdles for you. Then we'll dip into energy storage, which is, that basically means a battery for your home or business that allows you to use power when the grid goes down. That's a very popular topic. And then we'll talk about the incentives, and I'll go through a sample budget for a solar system, which is often of great interest of folks attending. And then we will talk about the process of installation and how to get started looking for a contractor. At the end, we'll have a Q&A, and I really love to answer questions. So we are here as an educational resource, and so please, any questions you think of during the webinar, I'll show you in a second how to put them in the Q&A box, but just know that I will be delighted to answer those at the end of the webinar. So a little bit about Solar Oregon. We are a 42-year-old nonprofit now, and I've been with Solar Oregon for the past 3 years. We provide education, outreach, and advocacy to increase the adoption of solar energy across the state. And we do that in a few different ways. One is through webinars just like this about solar energy for folks who are considering that for their home or business. We also have solar tours where you can go and talk to somebody who has adopted solar and hear how that has been for them. We also have Solarize campaigns. We're about to launch a Solarize campaign, fingers crossed, hopefully, in a few weeks in Hood River County. So if you happen to be in that area, feel free to ask me about that. And we love to tell stories. We're big on peer-to-peer education. We are a member-based nonprofit, so thank you to anybody who has joined, who is a member of Solar Oregon. Your support has made a big difference for us in the past. This is our donation link. If you want to donate, you can also go on the Solar Oregon website and become a member. I am going to drop some links, a whole glob of links in the chat. So you might see a little icon down on your chat, part of the menu bar for you. And that'll have links that I'll reference throughout the whole webinar. So you can see our website link there, as well as our events link and our donation link are the top 3 links in there. A huge thank you to Energy Trust of Oregon, who supports this webinar and actually a number of webinars and other events that Solar Oregon hosts. Energy Trust of Oregon is an independent nonprofit that provides incentives and supports education like this, all to help us use energy better in the state. And they serve customers of Portland General Electric, Pacific Power, Northwest Natural, Cascade Natural Gas, and Avista. And some of the solar incentives that I'm going to talk about are provided by Energy Trust of Oregon. So they actually do a lot of work to support solar. So the Q&A button is the one on the right that's in a little green rectangle here. And that's what you can click on. It might look slightly different on your menu, but it will say Q&A, and that's what you can click to enter any questions. Again, throughout the webinar, go ahead and click the Q&A button. You can also put things in the chat to say hi, things like that. But if you have a question, I'd rather you put it in the Q&A box, because that's where I'm going to be looking for questions. And if you put it in the chat, I might miss it. I do have some polls that I am going to launch. These are interactive. This is a great way for us to get to know who's joining. And it's also important for us to figure out who we're serving and how we can improve our programming. So if you wouldn't mind, I'm just going to run through a few of these right now. First one is, where are you joining from? And there's different parts of the state, or maybe you're from another state, or maybe you're from out of the country. We've had folks from all over. So just looks like most people have put in some answers. I'll just give a couple more seconds here. All right, thank you. I am going to launch our second poll, information about demographics. And there's a few questions there, so I'll leave that up for a minute. All right, I'll just give a couple more seconds. Great, thank you. And the last poll before we get started is just to assess your familiarity with a couple of the incentives offered by Energy Trust of Oregon. This helps us to figure out if we're doing our job educating you well about these incentives. So the first incentive is a standard incentive. If you don't know what that means, or you're not sure, you can click those options. Same thing with the second incentive, which is solar within reach incentive. Great. All right. Thank you so much for that. And let's go ahead and get started and take a look at how solar works. So this is a pretty basic diagram of a solar system. I'm going to walk you through this component by component. Obviously, the house is in the center here. Maybe that's your home. And up here on the left is the photovoltaic panel. That's the solar panel. It's just also called photovoltaic panel. The sunlight hits that. Maybe it's on your roof. Occasionally, you might have a ground mount. I'll show you some of your options there in a second. But the sunlight strikes that and it produces electricity. It produces a voltage. And that type of electricity is called direct current, DC electricity. If that doesn't mean anything to you, you don't have to worry about it. Just know that there are two types of electricity. There is DC electricity and there's AC electricity. All the circuits in your home use AC electricity, but solar panels produce DC electricity. So these electricity gets routed from the panel to a special box called an inverter, or maybe you have several microinverters, and those perform that conversion from DC electricity to AC electricity. Now the electricity is in a form that all of your lights and appliances and anything, an electric vehicle, can all use. And so it gets routed into your home electrical panel, and that's your breaker box that might be in your garage or somewhere else in your house. And from there, the electricity from your solar system gets routed to all of the circuits in your home. If you are producing more solar at any given moment than you're using in your home, that electricity then flows out of your house through your utility meter and onto the utility grid. And something to note is that usually when you don't have solar, you are only importing electricity from the grid. So it's a one direction flow from the grid to your home. When you get solar, it's possible to have that electricity flow in both directions, and you want to be able to track that. Well, your standard electrical meter, your utility meter, is typically a unidirectional meter that only tracks electricity flowing into your home. So when you get solar, your utility company will swap that out for a special meter called a bidirectional meter. And that's something that the utility company handles. That's it. It's pretty basic. And the great part is there are no moving parts to a solar system. And that's one of the reasons why they're relatively easy to maintain. This is what that special box looks like, the inverter or microinverter. On the left, you see an inverter, and that's the white box here, which here it's pictured on the outside of a house, can go on the outside of the house sometimes. Often it goes in the garage right next to the electrical panel. The picture on the right is a picture of microinverters, and those are these special black boxes here. You can see that there's a large number of them, one for every 1 or 2 solar panels. And those microinverters do the same exact things as an inverter. You might be wondering, well, how would I choose between inverters and microinverters? And the great thing is that solar contractors deal with this all the time. There are some cases in which a microinverter might make more financial sense, and some cases in which an inverter might make more financial sense. Your solar contractor will be able to explain that to you and give you a pretty good sense of what's a good fit for you. There are a couple of mounting options. The more popular option by far is a roof mount, and that's because your roof has the ability to host solar, and that's space that you're otherwise not using. And so it's really great, especially if you don't have ground space available, because with a ground mount, not only does that take up ground space, but you also have to route a wire from the array all the way to your electrical panel, and copper is pretty expensive. And so those wires that run long distances can actually be pretty expensive, on the order of thousands of dollars. But both are good options. And if you do have the space and you do want to consider a ground mount, that is certainly an option for you. However, roof mount is probably what you'll be looking at. So remember when I said that electricity will flow into your home from the grid and also out to the grid when you're producing more electricity than you're using with your solar system? The question you might have is, do I get credit? Do I get money for that energy that I'm sending to the utility grid? And the answer is that if you are a customer of Portland General Electric or Pacific Power, or of certain other electrical co-ops in the state of Oregon, they have a system called net metering that allows you to take advantage of that. And so I'm going to explain these two charts. The one on the left is a typical summer month. The height of these bars is how much electricity over the course of that whole month. And the orange bar is how much electricity you're producing with solar. The blue bar is how much electricity you're consuming with all of your lights, appliances, etc. So in a typical summer month, because those are sunnier here in Oregon, we will have, say, more electricity being produced. And you can see this green arrow is the difference between your production and your consumption. And that is the electricity you're sending out of your home onto the grid. And you get net metering credit when you have net metering. And you can use those credits later in a winter month. So on the chart on the right, you can see that your production, the orange bar, is less than your consumption, the blue bar. And so that red arrow is how much electricity you would have to buy from the utility company that month. But if you have saved up credits from the summer months, you can use that to offset what you would otherwise be buying from the utility. So in this way, you can use credits from month to month, and in that way, essentially save up credits that you can use later in the year. One thing to note is that although the credits roll over from month to month, they do not roll over from year to year. And so that means that you want to size your solar system to meet but not exceed what you expect to use over the course of a year. And that's something that a solar contractor is pretty good at. and they will handle that calculation for you, and they'll take a look at what you have used in terms of electricity from your utility bills, say in the past year or the past couple of years when they do that. That's the basics of net metering. If you understand net metering, you understand basically how solar works, and a central part of how you figure out whether solar is a good financial decision for you. So the end goal here is that we're reducing our energy bills, and the money that you can save on your energy costs over the course of the lifetime of a solar system, which can be 25, well, they're typically warranties last for 25 years, but solar panels, in fact, the first solar panels produced back in, I think, the 1940s, 1950s are still producing electricity. They do degrade very, very slowly over time, but they do last potentially for a very long time. So the amount of money that you can save on your energy over the lifetime of the system is actually quite large. So that's the basics of how solar works. Let's take a look at whether your home is right for solar. I mentioned a little bit about system sizing and how that is based on how much electricity you consume. That is the first thing I would say to consider when you're considering your system size. You want to meet but not exceed your annual average energy needs. Other factors that might affect the size of your system are available space. Maybe you use a lot of energy and you have a small roof, or your roof is broken up, and then you can offset a portion of your energy, but not all of it. Maybe you have the budget for only the ability to offset a portion of your energy. The great news is that it still has a great financial benefit proportionally to how much energy you're offsetting over the lifetime of the system. The couple notes here. The system size is measured in something called kW, that's kilowatts. You don't have to worry about what that means, but just know that the average size system in Oregon is about 6 kilowatts, which translates to roughly maybe 18 to 20 solar panels. The next thing you might consider when you look at whether your home is good for solar is how much access do you actually have to sunshine. So here's a little hypothetical home, and these are the cardinal directions, and you can see these orange globes are the sun traveling in its orbit over the Earth in an Earth-centric universe. And the sun rises in the east, travels in this arc, and sets in the west. Because we're in the northern hemisphere, the sun is always in the southern sky. And so south-facing roofs are ideal for solar panels. So if you have a great wide open south-facing roof, that's awesome. If you don't, you can still get away with east-facing and west-facing roofs. In fact, they work just fine, and they can pick up a lot of sunshine. North-facing roofs are a little bit trickier, and you typically do not see solar installed on a north-facing roof. Shade, of course, is a consideration. You may have a great south-facing roof, but if you have a massive tree, or maybe there's a building that blocks most of that sunlight, that can significantly impact the financial outlook of a solar system and how much energy it will produce. The good thing is that you are probably not a good judge of the shade that is blocking the sunlight that could reach your roof. It took me a while to develop a good eye. You may look at a home and think that it is, way too shady. There's way too many trees around it. But it could be that those trees are on the north side of the home. It could be that you only see the shade cast on the roof during the morning and the evening when you're, departing for or coming back from work or something like that. So don't give up hope just because you have trees around your home. It's very common that you still have enough sunshine, and it just takes a trained eye to look at it. And solar contractors sometimes actually use a special device. They'll get up on your roof and measure the path of the sun and how much material is shading the path of the sun. Conversely, also, if you sometimes you think you have a tremendous amount of sunshine and the shade is not really affecting you, but there could be that one object that's just due south of you or just in the right place that actually does block a lot of sunshine significantly. So you never can tell, and it's always best to get a contractor to take a look at it. Beyond shading and the direction of the roof plane, you also should consider the roof complexity. The picture on the left, these are just Google Maps images. The one on the left is a roof that has a very complex geometry, and it's better to have, like the image on the right, more of a wide open space where you can have a continuous solar array. And so you could conceivably, if you look at the image on the left, put some panels up on the upper right side of the south facing portion of the roof, maybe a couple panels on some of the other sections, but it's going to significantly reduce the number of panels overall. And the breaking the system up into several arrays is completely possible, and it's actually quite common. But if you break it up too much, it does increase the cost just a little bit in terms of the labor and the materials. And next, and this is probably the most important consideration for your home, is your roof condition. And that is because when you install solar on your roof, you want to keep it there as long as possible. And when you need to re-roof, you need to re-roof. You can't really get around that. And if you need to re-roof and you have a solar system, you have to take that solar system off, do the re-roofing, and then reinstall the solar system. And the labor cost of taking your solar system off and then reinstalling it after you re-roof can cost several $1,000s. And so you want to avoid that if you can. And so there's many different roof types. The two most common are asphalt shingle, like here, pictured here, that's the most common, and also metal roofs. You might see standing seam metal a lot. Metal roofs are great. They have very long lives. And in fact, standing seam metal roofs, you don't even need to have any kind of roof penetration. The solar systems just have clips that clip onto the seams that run down the metal roof. So standing seam metal roof is ideal for solar. Asphalt shingle also works great. However, asphalt shingle roofs, you have to be a little bit more conscious of the roof life. So for example, Energy Trust of Oregon, if they are going to give you incentive money, they will not do it if you have less than 10 years of roof life left. You really should have as much as possible. So if you are about to re-roof, or you think you might re-roof in the next 2 to 3 years, I would wait, re-roof, and then get solar. And finally here, I want to talk a little bit about roof structure. And what I'm talking about is, say, the difference between trusses, which is the image on the left, and rafters, which is the image on the right. And trusses, you'll just see these supporting beams, both on the side and also on the top here. And you'll see also these little connections, which are these metal brackets between those truss beams and the main rafters. On the right, you'll see no support beams. You'll just see the rafters going up from the eave to the crest. And both of these roofs could be just fine for solar. And the concern is not about the weight of the solar panels weighing down on the roof, causing any kind of downward force that is a structural hazard to your roof. What is of concern in some cases is the solar panels sit just a few inches above the roof. And as the wind moves over your roof, it can actually lift the roof up and apply an upward force. This is rarely, practically speaking, a hazard unless you live in a place with high wind speeds and your home is relatively old. Most places outside of Portland, most jurisdictions have relatively reasonable structural requirements. However, if you happen to live in Portland, the city of Portland proper, you will find that they have very stringent structural permitting requirements for solar. And so if you are in Portland and you look up in your roof and you see trusses, you should be A-okay. If you're in Portland and you look up in your roof and you see rafters, you may be A-okay. but you will have your solar contractor will probably have to take a look at that, may have to hire an engineer to make sure that it passes the structural code for Portland. Yeah, again, in other jurisdictions that are more reasonable, that's not really an issue because it doesn't practically create that much of a hazard. So that's a look at whether a few aspects of your home and whether your home is a good fit for solar. Hopefully that gives you a good idea, generally speaking. However, again, you're going to hear it from me over and over. Talk to a solar contractor if you have any doubts, because solar contractors will be able to sift through all the details and make sure that there's nothing that is a hurdle for you for solar. So let's talk a little bit about solar plus storage. And again, storage is another word for a battery. So there is a concept of energy resilience. That's just your ability to use electricity when the grid is down. And so if you have had a power outage recently, you probably remember some inconvenience around that, food in your refrigerator spoiling, not being able to charge a laptop, cell phone, things like that. Energy resilience is the ability to do those things. There's a common misconception that solar allows you to do that on its own, and that is not true. Solar actually has to shut down per national electrical code, because if it didn't shut down, your system would be sending energy out onto the grid, onto the electrical lines that utility workers are trying to fix at that time. So your system is designed so that it will shut down when the grid goes down, unless you have a battery. And so I'm going to talk about that in a second. These are some reasons in Oregon why you should think about energy resilience. There are, of course, outages that occur frequently just because of things like storms and actually squirrels chewing electrical lines. There are also newer reasons why your power may go out, like public safety power shutoffs. You may have, if you followed the news of wildfires down in California since around 2019, utilities down there started shutting off their lines and the power to thousands of homes in order to prevent their lines sparking a wildfire during high fire hazard conditions. And that's actually happened for the first time in 2020. That happened in Oregon, and utilities have let the public know that they may, in certain areas of Oregon, especially rural areas, and especially specific rural areas, you may experience some public safety power shutoffs. Additionally, the Department of Energy identifies cyber attacks as a potential threat to the grid. And of course, we live in the Cascadia seismic hazard zone. And it's predicted that when the Cascadia big earthquake hits, that the power will go off for up to 6 weeks in the Willamette Valley and potentially longer on the coast. So a great solution to this, to a certain extent, is batteries and solar plus storage. So this might look like a battery in the garage and solar on the rooftop. There are a number of batteries that are available in the market, and you may have heard of one or another. Just know that there are multiple options, and you can talk to your solar contractor. Some contractors only install one make of battery, and other contractors, you'll have several options, and you can talk with the contractors about what is the right option for you based on cost and the amount of energy it can store and performance and things like that. It is really, really important, if you're considering getting a battery, to set your expectations about what a battery can achieve. And that is because folks often have the conception that they will buy one battery and then they can endure any outage for any length of time and run any amount of appliances. And that is wildly inaccurate. A battery does you a lot of good, but you have to be strategic about how you use it. So I want to talk about the difference between a partial home backup and a whole home backup. A partial home backup is where you'll take certain circuits. So say you look at your circuit breaker, you'll pick say these 3 or 5 breakers, you'll move them over to a separate breaker panel and you'll hook that up to the battery. All your other breakers will go down when the grid goes down, but the ones that you back up will still have power from the battery. That's what a partial home backup is. And that is usually what you can achieve with one battery. A whole home backup, you can achieve with batteries, though it often takes 2, more often 3, sometimes 4 batteries to back up all of your appliances for a meaningful amount of time. So this is just an example of what a whole home backup might look like, where you have multiple batteries. So when you are thinking about the sizing of your battery system, do I want 1? Do I want multiple? You'll ask yourself 2 questions. One is, what needs power? And so that might be a refrigerator to make sure your food doesn't spoil, some lights in important areas, and a few outlets so you can charge a laptop, a cell phone, things like that. Those you might consider your critical needs. Do you really want to add a very high energy use jacuzzi? Do you want to add that pinball machine? Do you want to add a space heater? That's a tough question when it comes to battery system sizing. And you'll weigh what needs power against for how long you want it to have power. And that's a balance there that you can talk through with your solar contractor as they're sizing your battery system for you. Typical battery backup durations might be anywhere as little as 2 hours if you are just trying to prevent those really frequent but brief outages, to up to a day, maybe a few days if you are really sizing for long duration. This is just a look at what it's called the essential loads panel. I told you with a partial home backup, you'll take some of your breakers and put them in a separate panel, and that will be connected to your battery. So this will be a second breaker panel for you. So that's solar plus storage. Let's talk about the dollars and cents, because that's often where folks make their decisions about when to go solar or if storage makes sense for them. So the great news is that solar costs have declined significantly over the past decade. And this chart is just a couple years behind now, but it's the same basic trajectory extends into the future here, where you'll see that 12 years ago, prices were declining pretty quickly. And now that has kind of flattened out, but prices still do decline. This is because of improvements in the technology, as well as improvements in the size and scope of the solar supply chain. So costs are coming down. There are also great incentives to help you go solar. And I'm going to talk about each of these that are available to residential homeowners. If you're a business owner or you're considering solar for businesses, there are additional incentives, and feel free to ask about that in the chat. So there is a federal incentive that's available for any solar project, and that's called the Solar Investment Tax Credit. That is right now at 26%. The state of Oregon also offers a rebate called the Solar and Storage Rebate. That's up to $5,000 for solar and up to $2,500 for energy storage if the energy storage is attached to a solar system. And that is available to anybody in Oregon, regardless of your utility. The last incentive here is from Energy Trust of Oregon. This is their standard solar incentive that I mentioned in the poll in the beginning. And the standard incentive is different whether you're a customer of PGE, where it's $1,200, or Pacific Power, where it's $900. If you are not a customer of PGE or Pacific Power, you unfortunately are not in Energy Trust of Oregon territory, and you don't have access to those incentives. However, most people are customers of PGE or Pacific Power in the state of Oregon. So these are great incentives. One note is the Solar Investment Tax Credit, this federal incentive. That's a tax credit. You don't get that immediately. You get that when you file your taxes the following year for the year in which you installed solar. And so you have to have tax liability to take advantage of that. You can claim that tax credit over the course of, I believe it's 3 years. So if you don't have quite enough liability the year that you file, you might be able to take advantage of the next piece of it over the next couple of years. One important note is that this is a pretty big incentive. It is going down to 22% in January. And so you want to make sure your solar system is installed before then, if you want to take advantage of that 26% rate. There is one last incentive that I want to cover, and that is also an Energy Trust of Oregon incentive. This incentive is income qualified, meaning that if you are below a certain income threshold, you have access to this incentive. And it is a very sizable incentive. So in Pacific Power, if that is your utility, you can get up to $4,200 off your solar system. And if you are a customer of Portland General Electric, you can get up to $8,400 off your solar system. And it is a relatively generous income threshold. So for a household of 4, household income needs to be below $106,944. Again, if you look at the links that I put in the chat toward the beginning of the webinar, you'll find a link toward this incentive information page, and you can see the chart with all of the income thresholds based on your household size. So that's a great incentive. And here's just a little bit more information about the state of Oregon solar plus storage rebate. Again, that's solar is up to $5,000 max. Storage is up to $2,500 max. And the reason this is maximum is that it tops out at 40% of the cost of the system overall. The great news is that you'll virtually always max that out. And so you can just, practically speaking, unless you have a very small system, think of it as a $5,000 solar incentive. So this is, in addition to the next slide, typically everybody's favorite slide. Everybody wants to know, how much does solar cost? I'm going to walk you through a specific example. You should note that it is very difficult to actually quote a solar price without taking a look at your site. And so take this with a grain of salt. This is using very generic cost profile. However, you can hopefully get some insight into how much solar costs from this basic example. So I'm going to walk through 2 examples. One is, so this slide is for Portland General Electric customers. The next slide is going to be for Pacific Power customers. Say you don't qualify for solar within reach. So that's going to be this middle column I'm going to walk through. Then on the column on the right is if you do qualify for solar within reach. And so I'm going to walk through here the starting cost, say, for a 6 kilowatt system. So that's going to be widely variable again, because you may have a much smaller system, in which case that initial cost would be much smaller, or a much larger system, in which case that initial cost would be much larger. But let's say it's 6 kilowatt, and let's say we're starting with $20,000 upfront cost. Great. So if you don't qualify for solar within reach, your Energy Trust of Oregon incentive is $1,200 as a Portland General Electric customer. If you do qualify, it's $8,400. So that takes us down to these figures here. Then we'll apply the Oregon State solar plus storage rebate, and that is $5,000 for the solar. And that will bring us down to the out-of-pocket cost of the customer. This is what you actually pay up front, because these first incentives, the Energy Trust incentive and the state incentive, your contractor will apply for and receive those incentives on your behalf and pass those savings on to you. So really, for a non-income qualifying customer, you'll be paying, in this example, $13,800 out of pocket. Or if you do qualify for solar within reach, you'll only be paying $6,600. Then when you file for your taxes the following year, if you have the tax liability to take advantage of that in the first year there, you'll apply these figures, and the net cost of the system is the final row here, and that's roughly $10,000 for non-income qualified, roughly $5,000 for income qualified. So hopefully that gives you a good sense of A, the value of the incentives that you have access to, because we started with $20,000. We cut that in half for non-income qualified, cut it down to just a quarter for income qualified. And also generally what you might expect for the average size system in Portland General Electric territory. I'm not going to walk through all the same details for Pacific Power, but we start with the same $20,000 cost. We apply the $900 Energy Trust incentive, or if you're eligible, the $4,200 solar within reach incentive. And when you work this all the way down the sheet, the final net cost of your system is roughly the same as it would be in PGE territory for non-income qualifying customers. And it's about $8,000 for if you are eligible for the solar within reach incentive. Still a pretty good deal. And these costs are just the net upfront cost of installation. The solar system then, as I mentioned in the beginning, will save you money on your energy costs going forward. And so after the system has paid itself off, you'll be saving money and building wealth that way for your family. So that's the basics of how to think about the cost of a solar system. How do you get started with solar? The Energy Trust of Oregon also provides a really great system of rankings for solar contractors. And so solar contractors that qualify and meet all of the criteria of Energy Trust of Oregon can become trade allies of Energy Trust of Oregon. And if you want to take advantage of the Energy Trust of Oregon incentives, you have to have your solar installed by a trade ally of Energy Trust of Oregon. And so these are rigorously qualified contractors. I highly suggest that you take advantage of that. I'm going to go ahead and drop the links again in the chat just to bring them down here. There is a great tool if you are in the position where you're thinking, hey, I've thought about solar. I want to get some quotes now. I'm ready for that. I don't know how to choose a contractor. You can find this link in the chat under Energy Trust-Solar Bid Tool. And you can also just Google Energy Trust Solar Bid. And you will find this webpage. It's a 2 to 5 minute form. You fill it out with your information. Energy Trust of Oregon will find 3 of the most highly rated contractors that serve your area, and we'll send your information to those contractors and tell them to get in touch with you within 48 hours to offer you a free quote. And so when you do that, the contractor will come to your home. Potentially, some contractors don't even come to your home before they offer you a quote. They give you a preliminary quote that they might then come to your home and alter the quote based on what they take the measurements. But some contractors will come to your home. They might get on your roof, take some measurements, talk with you for a little bit, and then they'll drop a quote for you. And this is a great way to figure out, to get 3 quality bids for solar. So once you have done that and you've decided on your company that you want to install your solar system, it's pretty much a turnkey service. So you sign the contract and you might pay a little bit upfront, or you might pay all of it upfront depending on how the contract is structured. And you can of course get financing for that. But once you sign the contract and things are set in motion, your contractor will do all the work for you. So they complete the paperwork, they design the system, they get all the permits, then that might take a couple of months, and eventually they'll get you on their construction calendar. So you might be waiting a couple of months, but then when you actually get your solar installed, it's typically pretty painless, just 1 or 2 days. For a typical residential system, it's often just 1 day of installation. Then you might wait for a couple of weeks while your system is being inspected. Your contractor will coordinate all of that, and they'll also coordinate your meter swap to get you your new bidirectional meter. And they will coordinate having the utility interconnect your system and give you the green light to turn your system on, and then your contractor will turn your system on for you. And once it's turned on, you have your solar system and it's producing clean energy, and it's a great feeling. So that's the process, and that is the end of your solar journey. So we're now at the Q&A. So I hope that this has been informative for you. I hope that you have enjoyed this webinar. I do want to answer all your questions, so go ahead and put those in the Q&A box. I also do have one more poll, and this is our post-event survey that we started doing as a Zoom poll. And I really appreciate your answers here. This will help us to improve our webinar in the future. So please, if you would just answer those questions real quick, and then I will start to answer some questions if you put them in the Q&A box. Also happy to answer questions about things related to solar, like electric vehicles, heat pump water heaters. We'd like to take a holistic look at energy usage, and there are a lot of really interesting and exciting technologies and things going on in energy. So, all right, I see a Q&A question. Chuck asks, can you talk a bit about storage retrofit? We had the solar installed several years ago and opted out of storage at that time. Yeah, that's a great question. So it's a very common question. Can I install a battery now that I already have solar? And the answer is yes. So there are two different types of energy storage systems, and it's about how the battery is connected to the solar, and they're called AC coupled or DC coupled. And if you install a new system, you might have a DC coupled system, which means that both the battery and the solar are on one side of the inverter. And if you have an AC coupled system, it'll mean that you have to have a second inverter installed. And so it does add just marginally more cost sometimes to add storage after you get solar. But it's really not all that much, and it's entirely possible. So definitely possible. Yeah, if you have any other questions about that, feel free to, or follow-up questions, feel free to put those in the Q&A box. And thank you all for completing the post-event survey. All right, Brian, you ask, can you talk more about system sizing? My electric bill shows my current usage, but if I go solar, I may want to switch to an electric water heater, electric heat pump, etc. Yeah, that's a great consideration, and you should definitely be thinking about that. Your solar contractor may ask you about that when they're trying to size your system. So of course, when you adopt, say you're using gas for your water heating, and then you decide to add an electric water heater, that'll increase your electrical load. And it is possible to approximate what that additional electrical load would be based on the appliance that you're choosing, your water heater, or a space heater, say a heat pump. And based on the energy consumption that you use in terms of your gas for those same functions. It's a little bit complex, and so it's a little bit ballpark of an estimation sometimes. You can get super fancy and do some energy modeling, but that's typically not what you'll do in that situation. But it is very common, and so definitely just talk about it with your solar contractor. All right, I'm gonna go ahead and end the poll there. Thank you all so much. And if there's any other questions, I'll stick on here just for another half minute or so. Otherwise, we can call it a webinar. All right, I'm gonna go ahead and wrap up unless I see something tick on the Q&A box here. Really great to have all of you. We have a lot of events this month, so please check out our website. Oh, we got one more from Brian here. What if you oversize your solar system? Do you just end up giving away the electricity? Are there any other downsides? Yeah, the only downside to oversizing your system is that you won't reap the financial benefit of it because the way net metering is structured is that your credits don't roll over from year to year. And those extra units of electricity that don't roll over, those credits that you lose at the end of the year, do technically get donated to a fund that supports low-income ratepayers. And that's managed by the utility company. However, there's, and that's something that some folks do. Often folks want to maximize the return on their investment in solar. And so they'll try to exactly match their needs and not go over. All right. Well, thank you all so much. Please check out our future events and be in touch. My email is also in the chat there if you want to jot that down real quick. I'm happy to answer questions and to help point you in the right direction as you go along in your solar journey. So thank you for joining us, and we'll see you next time.